For number 2, we've got x squared times sine of x dx. So we need to figure out what's our u, what's our dv, so that we can then figure out du and v. So x squared sine of x, neither one's really harder than the other necessarily. So what we want to look at, the big thing is what we get for du and v, because those are going to end up inside the integral, right? From our formula, they're going to end up in here. So we want those to be as nice as possible to make it easy for us to do that antiderivative. So if we let's look at sine of x first. If we had u as sine of x, derivative of sine of x is cosine of x. Pretty simple, not too bad, right? If we had dv as sine of x dx, antiderivative of sine of x is negative cosine of x. Not much more complicated, right? Just a negative sign. So that would work either way, right? Neither one's really much different than the other. Let's look at x squared. If we had u as x squared, what's du? 2x. If we had x squared dx over here for dv, what's v going to be? 1/3 x cubed. So what do you think is better, the 2x or the 1/3 x cubed? 2x, right? That's going to be a little simpler, a little neater, a little bit easier to deal with in that second integral that we're going to end up with. So that's why I'm going to make u equal to x squared. And then du is 2x dx. dv is going to be sine x dx, and antiderivative of that is negative cosine of x. Alright, so those are the things you want to kind of think of as you're setting up the u and the dv. Just have to keep in mind that v and du are inside the integral, so we want those to be as simple as possible. So we're going to get u times v, so x squared times negative cosine of x, so I'll put the negative in front, negative x squared cosine of x, minus antiderivative of v du. So we've got that negative there, so I'm going to change this minus to a plus, and we end up with 2x cosine of x dx. So once we've set up that formula for integration by parts, we need to look at this new integral and see how can we do it. Sometimes, like number 2 in your starter, you can just do the antiderivative as is. There's no special trick. Sometimes you have to use u substitution like you did in number 1 from the starter. And sometimes you may have to use integration by parts again. So this one, obviously, we can't just do it as is. So next thought might be u substitution, but there's really nothing we can set as u. There's nothing inside of another function that we would set as u. We have two things being multiplied. So that means we're going to end up using integration by parts again. So this time, if you look at it, it's still pretty similar to before. We have 2x cosine x. Before we had x squared sine of x. We're going to kind of take the same route here. We're going to make the 2x our u. Du then is going to be 2 dx. dv is going to be cosine of x dx. So the antiderivative of that is just sine of x. So this first part stays out in front, negative x squared cosine of x. Plus, this integral now gets replaced with our integration by parts the second time around. So we're going to have u times v, which is 2x sine of x, minus antiderivative of v du. So minus, I'm going to go ahead and put the 2 in front of the integral, and then we have sine of x dx left inside. Right, now that one's one we can evaluate without doing anything special or fancy. We can just evaluate antiderivative of sine of x. So antiderivative of sine is what? Negative cosine. So that's going to make this plus 2 times cosine of x, and we need to remember our plus c at the end.